Welcome back to another demo of EDR Workbench. My name is Andrew Tan. I'm one of the founders of Entrust. And in this demonstration, I will show you how you can create, or rather configure, a TAP3 ASN.1 based format within EDR Workbench within a few minutes. And not just configure the format, but also be able to actually view a TAP3 file and modify the content and so forth. So what you see here is the starting screen of EDR Workbench, the configuration environment of EDR Workbench, and we'll start right away by creating a new factory. So I'm going to create a new factory and I will call it my TAP. I will use the TAP3 ASN.1 format, my TAP3 factory. Okay. Excuse me. So that creates a new empty factory, and the first thing I'm going to do here now is, because I just want to be able to read and write TAP3 and look at the content of a TAP3 file, all I need is a file input. So I have the file input bot, and I'll drag a file output bot because I also want to write the TAP3 format, so I can now read and write it. So now I have two generic file input and output bots on my canvas here, and I'll start off by giving them a name, and I'll name this TAP3 input, and I also have to configure directories and files where the actual if we're working in automated mode, we would have to automatically read the file somewhere and write the file somewhere, where that would be. So I have an environment variable here that I'll use, and it's called basedir EDRW data basedir. That points to my basic EDR Workbench data directory, and there I will read the files from here. If in automated mode, I will not show the automated mode in this demo, but just for completeness, I will fill this in. File prefix for files to read is this, is IN, and the temporary directory, I will just use the same directory, done directory. What am I going to do with the file once I'm done reading it? I'll just write it to a directory called done, and should be prefixed with the word done. And for the error case, I will write it to a directory named error. Just mind you, these directories actually do have to exist. EDR Workbench is not creating them automatically. So I'll call that error. So that defines the directories. And going back to the format, here I would usually select the format that I want this file input bot to be able to read. But since I haven't configured the format yet, I'll have to revisit this once I have configured the format. So I'm done with the input bot now. You see this little red dot with the white cross in it. Means it's not completely configured. That just indicates that the grammar is missing. So I'll do the same on the output side. I'll name that TAP3 output. You can just pick any name you like, really. And here also can't configure the format for this output or pick the format for the output at the moment because I haven't configured it yet. So I'll start off with configuring the output directories, and here I'll write that to a directory called out. I'll prefix the file that's being output with the word out, and temporary processing also. While the file is being processed and written, I'll also write it to the out directory, and I'll prefix it with temp out. Okay, so that should take care of that. And again, here I have the red dot, which indicates that there's some piece of configuration missing in this output bot here, which is, again, the grammar is missing. So I have configured my basic data flow now, which is just reading something and writing something, and there's this line in between, this link, which says that that's where the data will travel, and later on, when the factory is running interactively, we will be able to see the CDRs as they flow across this link here, and that gives us the capability to then actually browse and edit the content of a TAP3 file. So now to the more interesting part, we'll have to define the grammar for the TAP3 format, and the TAP3 format is quite complex, and it's all defined in an ASN.1 grammar notation. So to define a grammar, we have a grammar editor here, and we use that grammar editor for all types of formats. Let me just invoke that real quick. Just click on it. It brings up a new tab, grammar editor, and as you can see here, we basically have 4 categories of grammars: ASN.1 grammars, RxP grammars, as we call them. These are for any kind of ASCII, very complex ASCII and binary types of formats, with SOAP grammars, XML grammars. So we want to create an ASN.1 grammar, so I click on ASN.1, I say new grammar, and give it a name, TAP3 and it's of type ASN1. I'll say OK, so it gives me a new structure here. TAP3 libraries, projects, and now I want to add a file which actually defines the ASN.1 grammar. So when we're configuring ASN.1, all we need is the original grammar definition. And to put that in here, I'll right-click on that node and say Add New File. I'll call that TAP3 and that will hold my actual ASN.1 grammar. Hit OK. Opens an empty editor. And like in a cooking studio, I will now copy the actual ASN.1 grammar from an editor into EDR Workbench. Watch this. And if you don't believe me, what I did here is I really just copied the original TD57 3.11.2 ASN.1 grammar notation into EDR Workbench, and you can just scroll through, and it's just the original stuff. So that pretty much defines the grammar. We're not quite done yet. We have to let EDR Workbench know, because as we know from the specification, we know that the TAP3 grammar is divided into a classical header, detailed trailer format. So we have to let EDR Workbench know, how do I identify what's a header, how do I identify what's a trailer, and how to identify what are detail records. And we call this the mapping. And that's not to be mistaken by mapping from one format to another, but it's really just to define how to identify several record types. So what I've done here now, while I was talking, is I hit this mapping button here, and in this mapping tab that comes up, you can actually define these external context to how EDR Workbench should handle these records internally using this mapping screen. And so I'll right click on here, I'll say Add Mapping. And the first thing that it asks me for is what's the ASN1 context name for that mapping. And so I know from the specification the ASN.1 context name for the header is called data. That's the data interchange block. So that's this one, which is a choice of transfer batch, notification, and so forth. So to point to that, I'm just copying the main block, and I insert 2 colons, and then say this block here that identifies a header, and then I can give it my own name, and I'll name it header. So that's what it will show up internally as with the word header. And here I'll just put in roots. It's really not that important. At the moment, you can derive record types from each other, so it doesn't really matter what you put in here for now. We'll just put in root. And here I give it my own element name, and I'll make it non-optional. So then I'll add another mapping for the detail. And again, I go back here. I say the main block name is this. 2 colons, and the detail is identified by the block call event detail. And again, I know that from the specification. So that's how a detail could be identified, and I'll name that internally detail, and it's the same element structure name. And so the last thing that's missing is the trailer. Again, I copy the main block structure name, 2 colons, and the trailer is identified by this block, and then within that block there is the so-called audit control info, and that defines the trailer. So now I should have 3 block structures. Oops, fill this in. I have 3 block structures that are pointing to the actual ASN.1 grammar, and this is how I named them internally. So that does that. And then there are some binary coded decimals in this format, which I know of, and to make them readable within this interactive environment, I want to convert them to something readable. So we have the option to define so-called converters, and we have let me click on that, and here I can say how I want certain certain data types within any format be interpreted within EDR Workbench. And let me show you that by looking at within the TAP3 ASN.1 structure, we have something that's called the BCD string data type. And where is that? There, for example. So in address string digits comes in BCD string, and BCD strings cannot be read by humans just like that. So to make that easier to work with, we can say we want to convert the BCD string data type to an ordinary string. And to do that, we have these so-called converters. And here I can add a converter, and I can say again the structure, main structure name, and then oops, what's the I want to copy this. I copy this in here. So BCD strings should be converted to, and now I can pick from a list, and we have here BCD string converter. These are ready-made converters for a number of structures that you come across most of the time when trying to read formats of all shapes. There are, however, some structures or some fields that are bitwise encoded in some vendor proprietary format and specification, and for those cases you can actually write your own converters using EDR Workbench and using EDR Workbench's own language. So you don't have to go back and ask us to write a converter to be able to interpret or read a field, but it's something that you can do. But that's not part of this demonstration. In this demonstration, we'll be happy just using the inherent bare BCD string converter. So that takes care of that. So that was all for the definition of the TAP3 grammar. So what we've done is we have copied the ASN.1 grammar from the specification. Then we have defined the mappings of how to identify a header, detail, and trailer, and we have defined one converter that converts binary code decimal strings into readable strings. So let's save that. Save all of that, by the way. And so we're done with the grammar. Now we have to go back to the network editor and actually let our file input and output bots here know that they should now work with that grammar that we have just defined. To do so, I have to activate that grammar, because by default all grammars that are newly configured in the system are deactive. So I can go into the so-called grammar store. The grammar store is the access point for all grammars that are configured within the factory. So that having said that, that means you can configure any number of grammars or formats that you want to work with at the same time, and you can access them here. I double click on that, and that brings up the configuration, and here I can see the ASN.1 grammar. That's the grammar I've just defined, and here I can also enable that grammar, and now I can actually use that. So now that I've enabled it, let me go here and double click on the input bot, go on configuration to the format. So now I can say this input bot should read an ASN.1 grammar, and it should read this one because that's the only one that's there, and the only one that we have defined. It doesn't have a block length, no petting bytes and all that. So just hit OK. So the red dot is gone now. Do the same thing on the output side. Go to the configuration because we want to read the format. We also want to write the format. So when we don't change anything while we're looking at the data, the output should be identical with the input. And here again, I just say ASN.1, TAP3 ASN. That's what this output bot should write. And here you have a number of options that we're not going to use for now. That's the end of that. So now we should be finished with configuring not just the format, but also having configured a factory which is able to read and write that format, and which we can now use to interactively look at TAP3.11 data. So let's save that. Let's close this. And now this is the factory I've just modified here, or created rather. And to run that, I have to check it into one of the EDR Workbench servers that I have in access here. And here in my environment, I have two. I have a local EDR Workbench server, and I have a server somewhere here in the network. And I want to check it into my local repository server, local EDR Workbench server that's also running here on my laptop. So all I do, and you can see there's a number of factories already checked into that server, but I will take this now from my local checkout directory where I have created this factory. Right click on that and say check in factory, and it will ask me where do you want to check it in to, and I say that's my local server, and I just hit OK. And EDR Workbench now transfers the complete configuration over to the EDR Workbench server that happens to run on the same machine here. But if it were on a remote machine, it would just take care of transferring the whole configuration over to that server, regardless of whether it is a very small a configuration or a very large one. It doesn't really matter. EDR Workbench knows what belongs together and what has been changed. So close that check-in window, and now I should be able to see that factory that I just checked into this server here, and that's the one. So now I want to run it. Right click, I say activate the factory, and hopefully it's just going to start. It has not started, so there is an error in here. What did I do wrong? Oh, okay, so I made a mistake. There's a typo, unknown grammar, TAP3 ASN. And well, let's go back and see where I made that mistake. So to do that, it's actually quite good that this happened. I just double click again on my local factory, and I look at the grammar. I probably made a mistake somewhere in the grammar. And let's see, so I already see that. I made a mistake here. Here's a typo. It should be TAP -0311 BCD string. So save all of that, close again, check it back in to the server. You see this is all done fairly quickly. I hope you can kind of follow at least. And here's the modified factory. Now I'll try to run that again. And what happens now in the background, hopefully, yes, now it works, is the EDR Workbench server gets a signal to activate the my TAP3 ASN factory, and look at the configuration, look at the data flow that we have configured, look at all the grammars that we have configured. In this case, it's only one, and built dynamic parsers for all the grammars that have been configured. In this case, the TAP3 ASN grammar, and also build a factory that's able to process the data flow that we have configured. So, which in this case is just one input and one output. If we had some business logic in it, it would also start to compile and create logic or the actual code for processing that logic. But you can tell now the factory is up and running on that server, and what we want to do is we want to interactively view and edit TAP3 ASN. So I can not only start that factory, but I can actually go into what we call monitor mode or monitor browsing mode. And for that purpose, I just right-click on the running factory. I say monitor browsing. What happens now is the graphical user interface connects to the server and presents me with a new dialog. It's called the data record browser. And the data record browser is connected to EDR Workbench to the running factory, and it comes up with a dialog that asks me to input data. And it presents me with all the input bots that I have configured within that factory. In this factory, it just happens to be one. We only have one input bot, one file input in this case, and I named it TAP3 input, so that's the only choice I have here. And it asked me for an input file. And remember, we're in interactive mode, so I'm just manually feeding stuff into it now. And I have a number of sample files here that I can pick from, sample TAP3 ASN files, and I'll just pick this one and hit OK. What happens now, the file is being passed on. Let me close this here so you can have a better look. What happens now, the file is being passed to the server, and the server starts processing it in the background and shows me the results. And the results in this data record browser look like this. Here in the top left corner, we have individual CDRs as they have been read by the server and been processed. And here on the right hand side, that should look familiar. That's the factory layout. And here we see a red dotted line, and that means the CDR that I've clicked on here is right now traveling on this line. It's not very impressive in such a small factory, but imagine you had a quite large factory with a lot of stations or bots that are interconnected, and you could then see the CDR traveling from bot to bot, and you could investigate the content of the CDR on each of these lines. So in this case, we're happy with just one line because all we want to do is really look at the content. And here, I just click on record number 7, for example. I can now see below here the details for that CDR. And here I see it's a detail record. The element name is TAP3 ASN. I named it that way. It is a mobile terminated call, and this is all the information that's in there. And I see the IMSI number now, for example. What's interesting is that here on the right hand side, I have a full representation of the internal format that has been dynamically built. And what you will see is EDR Workbench doesn't really have an internal format, but it's more or less a superset of all grammars which have been configured within any given factory. So here I can now actually see all the possible structures within ASN within the TAP3.11 ASN.1 format. So for a mobile terminated call, I can tell here these are all the possible fields that we could have in this structure of a mobile terminated call, and then we can look at the same thing for a mobile originated call, and so forth. So I can just browse through here now and investigate the content. I can use the IDF viewer to filter out stuff that I don't want to see. So I could, for example, say for mobile terminated calls, which number 7 was, for example. Let's see, find another one, mobile terminated call. I don't want to see the whole structure, but the only thing I want to see is I want to see the let's say I want to see the IMSI. So I activate that here, and all I get to see from any mobile terminated call is the IMSI. And I can do so for all the other structures as well. So mobile originated calls, for example, I left active, so I get to see all the data within the mobile originated call. There's a bunch of stuff you can do that makes your life a lot easier investigating the content of any given format that you have configured within EDR Workbench. So, and furthermore, I can even go in now and say, well, for record number 2, for whatever reason, because I need to have this, I want to create a test CDR with a different number, I'll just put in a different phone number that was called, and that was 49172918444, which happens to be my cell phone number. And I have now changed that here visually. To really change that in the file, I'll have to actually save that back. And to do so, I just have the save button. And what happens now is all of a sudden I have two records number 2. One is the original one, and you can tell here the call number is still the old one, and it's all grayed out. And one is the new record number 2, and you can tell here version number 1 of record number 2, version number 2 of record number 2, and that actually contains the changed number. So EDR Workbench, while we're looking at the file, keeps track of changes. To actually write the changes, I have to close the file. So I close the file now, and only the changed record number 2 will be written out. The original one will be discarded. So let's look at a different CDR file. I'll just pick another one. Browse local files, go a different directory, maybe look at this file. And there we have another file with other CDRs and so forth. So I can really walk through all the, let's take out the filter again. So I can see all the content of mobile originated calls. I can really see all the content now, and of TAP3 ASN files. And it works the same way for all formats that you can think of. The only difference being that the effort to actually do the configuration can vary. So it takes a lot longer if you have to sit down with the 500-page specification from Siemens and actually go through it and understand the structure and all that. But then you can just transport what's in the specification one-to-one to EDR Workbench and type it into an editor. And for binary and ASCII formats, for example, we have a different editor than for ASN.1 and so forth. But it's built in such a way that you never have to worry whether you can actually configure a format, or yes or no. You can always do that, and we have configured formats in the 3 digits, so we never had a real issue with that. But this really just demonstrates how to do TAP3 in a few minutes using EDR Workbench. And then now you can take it from here and add some logic on what you want to do with the data while it's being processed. Maybe you want to analyze it, change it, enrich it with some other information, split up the stream, filter out CDRs and all that. But that's part of another session. So I hope that was an impressive demonstration of the capabilities of EDR Workbench. And hope to see you again in another demonstration. Thanks a lot.